Welcome to this peaceful journey through our solar system. Find yourself in a comfortable position, somewhere safe and warm, where you can completely relax. Allow your body to sink deeper into whatever surface supports you right now. Feel the weight of your body being held, fully supported, as you prepare to drift through the cosmos on a gentle wave of fascinating, calming knowledge. Take a slow, deep breath in through your nose, filling your lungs completely. Hold it for just a moment. Now exhale slowly through your mouth, releasing any tension you've been carrying. With each breath, you're becoming more relaxed, more at ease. Your shoulders drop away from your ears. Your jaw unclenches. Your forehead smooths. You are safe, you are comfortable, and you are ready to learn about the quiet wonders that drift through space, far above our everyday concerns. Tonight, we'll explore the planets of our solar system, but not in a way that requires your focus or attention. Instead, let these facts wash over you like gentle waves on a distant shore. Some will capture your interest, others will simply flow past, and that's perfectly fine. There's no test, no need to remember anything. This is simply a peaceful journey through space, where the vastness of the universe reminds us how small our worries truly are, and how deeply we can rest in this moment. Let's begin our voyage with the planet closest to our Sun, Mercury, the swift messenger. Floating closest to the Sun, Mercury moves through space in peaceful solitude. This small planet, barely larger than our moon, traces its path around our star in just 88 Earth days. Imagine that, an entire year passing in less than 3 of our months. Mercury doesn't rush, despite its name suggesting swiftness. It simply exists in its own rhythm, completing its circular dance again and again, year after year, for billions of years. The surface of Mercury is ancient and quiet. Craters cover its gray landscape, each one a frozen moment in time, created millions or billions of years ago when asteroids and comets collided with this small world. These impact sites remain undisturbed because Mercury has no atmosphere to weather them away, no wind to erode their edges, no rain to fill them with water. They simply exist, peaceful monuments to cosmic events long past. The largest of these craters is called Caloris Basin, stretching over 900 miles across. Inside this ancient impact site, the surface has cracked and buckled, creating patterns like the dried mud of an ancient lakebed. But unlike Earth's lakes that change with seasons, these patterns have remained unchanged for countless ages. One of Mercury's most soothing qualities is its silence. With virtually no atmosphere, there is no sound. No wind whistles across its surface. No thunder rumbles. No waves crash against shores. If you could stand on Mercury, you would experience absolute, complete silence. The kind of silence that wraps around you like a blanket, where even your own heartbeat seems to echo in your ears. This is the silence of space, pure and undisturbed. The temperature on Mercury tells a story of extremes existing in perfect balance. During the long Mercurian day, the side facing the sun heats to over 800 degrees Fahrenheit. But Mercury doesn't complain or resist. It simply absorbs the sun's energy, its rocky surface warming in the cosmic light. Then, as Mercury slowly rotates, that same spot eventually turns away from the sun, entering the long Mercurian night. Without an atmosphere to trap heat, the temperature plummets to nearly 300 degrees below zero. This dramatic shift happens gradually, over the course of Mercury's slow rotation, which takes 59 Earth days to complete. Here's something wonderfully strange and calming about Mercury. If you were standing on its surface, you might see the sun rise, then stop, reverse course and set again, then rise once more, all in the same Mercurian day. This happens because of the relationship between Mercury's rotation and its orbit around the Sun. At certain places on Mercury during certain times in its orbit, this cosmic dance creates this peculiar effect. The Sun appears to perform a slow-motion dance across the sky, forward and back, like a meditation in celestial mechanics. Mercury has no moons. It travels through space accompanied only by its own shadow, cast by the Sun. There's something peaceful about this solitude. Mercury doesn't need companionship. It doesn't require satellites to feel complete. It simply exists, turning slowly, orbiting reliably, being exactly what it is, a small, dense ball of iron and rock, doing its cosmic duty without fanfare or complaint. Scientists believe Mercury's core makes up about 60% of the planet's total mass. This enormous iron core, larger in proportion than any other rocky planet in our solar system, generates a magnetic field. Though this field is much weaker than Earth's, it's still there, a gentle magnetic presence surrounding the planet. This field interacts with particles streaming from the Sun, creating a miniature magnetosphere, a bubble of magnetic influence in space. Even tiny Mercury has its own sphere of influence, its own way of affecting the space around it. The surface of Mercury is covered in something called regolith, a layer of dust and broken rock created by billions of years of impacts. This regolith is very fine, almost powder-like, similar to the surface of our moon. If you could scoop up a handful, it would feel soft and silky, flowing between your fingers like the finest sand. This dust has been there for so long, undisturbed by wind or water, settling into its own permanent peace. Mercury has permanently shadowed craters near its poles. These are places where sunlight has not reached for billions of years. Scientists have found evidence of water ice in these eternal shadows. Even on a planet so close to the Sun, where the day side bakes at extreme temperatures, these dark craters remain cold enough to preserve ice, perhaps delivered by comets long ago. This ice sits quietly in the darkness, year after year, millennium after millennium, waiting in its frozen sleep. The color of Mercury's surface is a subtle palette of grays and browns, with occasional patches of lighter and darker material. If you could see Mercury with your own eyes from a spacecraft, it would look somewhat like our moon, but with its own unique patterns and shading. The Sun appears 2.5 times larger from Mercury than it does from Earth, dominating the sky during the day, but from Mercury, you wouldn't perceive its brightness the way we do because there's no atmosphere to scatter light into a bright blue sky. Instead, the sky remains black even during the day, filled with stars, with the large pale disk of the Sun providing intense illumination to the surface below. Ancient astronomers knew about Mercury. The Babylonians called it Nabu, after their messenger god. The Greeks originally thought they were seeing two different objects, one in the morning sky and one in the evening, before realizing it was the same planet. They eventually named it Hermes, and the Romans later renamed it Mercury, their version of the messenger god. For thousands of years, humans have watched this small dot of light moving swiftly across the sky, never straying far from the Sun, rising just before sunrise or setting just after sunset. Mercury takes its time rotating. While it speeds around the Sun, its rotation is locked in a 3:2 resonance with its orbit. This means that for every 2 times Mercury orbits the Sun, it rotates on its axis exactly 3 times. This creates an interesting effect where one Mercurian day, from sunrise to sunrise, takes 176 Earth days, exactly 2 Mercurian years. Time moves differently there, flowing in its own unique pattern, unhurried and unchanging. Let your breathing match Mercury's pace. Slow, steady, unchanging. Mercury doesn't worry about its proximity to the Sun or the temperature extremes of its day and night. It simply exists, following the path it has traced for over 4 billion years, a path it will continue to follow for billions more. There is something deeply restful about such constancy, such reliability. As you breathe, imagine Mercury slowly turning in space, half in brilliant sunlight, half in star-filled darkness, perfectly balanced, perfectly itself. Venus, the evening star. Drifting farther from the Sun, we encounter Venus, Earth's closest planetary neighbor, often called our sister planet because of their similar sizes. Venus shines brighter than any star or planet in Earth's sky, earning it names like the morning star and evening star, though it's neither star nor twin but its own unique world, wrapped in mystery and moving through space in its own singular way. Venus is covered in clouds. Thick, unbroken clouds that never part, never reveal the surface below to outside observers. These clouds form a smooth, cream-colored blanket that completely encircles the planet, reflecting sunlight so effectively that Venus becomes the brightest natural object in our night sky after the moon. If you could float above Venus, you'd see these clouds forming subtle patterns, swirls and waves of slightly different shades, cream and pale yellow, moving in the thick atmosphere like slow currents in a cosmic ocean. The atmosphere of Venus is heavy, so heavy that if you could stand on the surface, the atmospheric pressure would be 92 times greater than Earth's pressure at sea level. Imagine diving deep underwater, down where the ocean's weight presses in from all sides. The pressure on Venus is similar to what you'd experience about 3,000 feet beneath the ocean's surface. This thick atmosphere wraps around the entire planet like a dense, warm blanket, creating a profound stillness at the surface. That blanket is made almost entirely of carbon dioxide, with clouds of sulfuric acid drifting high in the atmosphere. These acid clouds might sound harsh, but they're so far above the surface, between 30 and 40 miles high, that they create their own ethereal layer, separate from the world below. These clouds move quickly, whipped around the planet by winds that circle Venus in just 4 Earth days, even though the planet itself rotates much, much more slowly. Here's one of Venus's most extraordinary features. It rotates backward compared to most other planets. While Earth and most of its siblings spin counterclockwise when viewed from above the North Pole, Venus spins clockwise. Scientists call this retrograde rotation. No one knows exactly why Venus turns this way. Perhaps a massive collision early in its history knocked it into this backward spin, or perhaps the thick atmosphere created torques that gradually reversed its rotation over billions of years. Whatever the cause, Venus maintains this contrary motion, turning against the cosmic grain, unbothered by its uniqueness. Even more remarkable, Venus rotates very slowly. One complete rotation takes 243 Earth days. This means a day on Venus, from one noon to the next, is actually longer than its year, which takes only 225 Earth days. Time moves strangely on Venus, with days longer than years, and the sun rising in the west and setting in the east because of that backward rotation. If you could stand on the surface and see through the clouds, you'd watch the sun rise very, very slowly in the western sky, take almost 60 Earth days to cross overhead, then set very, very slowly in the east, all in perfect silence and slow motion. The surface of Venus is hot, extraordinarily hot, the hottest of any planet in our solar system. The thick atmosphere creates a runaway greenhouse effect, trapping heat so effectively that the surface temperature reaches about 900 degrees Fahrenheit, hot enough to melt lead. This heat is constant, the same at the equator and the poles, the same during the long day and the long night. Venus maintains this steady temperature, unchanging and stable, for year after year, era after era. Despite this heat, there's something oddly soothing about Venus's constancy. The surface never experiences weather in the way we know it. No rain falls, no storms rage at ground level, no seasons change. The thick atmosphere creates such stable conditions that the surface exists in a kind of timeless state, where every moment is like every other moment. Ancient lava flows from volcanic eruptions that happened hundreds of millions of years ago still look fresh because there's no erosion to wear them away. Venus has mountains. Ishtar Terra in the northern hemisphere rises high above the surrounding plains, with Maxwell Montes, Venus's tallest mountain, reaching over 7 miles high. These peaks stand silent and unchanging in the thick, hot atmosphere. Near the equator, Aphrodite Terra stretches across a vast area, larger than Africa, another highland region that has existed for ages. Between these highlands lie vast plains covered in ancient volcanic rock, plains that stretch for thousands of miles in gentle, rolling terrain. Volcanoes dot Venus's surface. Scientists have identified thousands of volcanic features, from small cones to massive shield volcanoes that dwarf anything on Earth. One shield volcano, Mont Mons, rises over 5 miles high. These volcanoes may or may not still be active. Some research suggests recent eruptions, perhaps within the last few million years, which in geological terms is practically yesterday. But whether they erupt or remain dormant, these volcanoes have shaped Venus's surface into the landscape it wears today. Strange circular features called coronae cover parts of Venus. These are unique to Venus, round or oval patterns where the crust has been pushed up or pulled down by hot material rising from the planet's interior. Some coronae are over 1,000 miles across, enormous circular structures visible only from space, like celestial mandalas etched into the planet's surface. More than 500 of these features have been mapped, each one a frozen record of Venus's internal dynamics. The clouds of Venus have their own form of lightning. Not the lightning we know from Earth, but something different, a form of electrical discharge that happens in those high-acid clouds. Spacecraft have detected what might be Whistler waves, electromagnetic signals that suggest lightning, though it might be different from Earth's lightning in frequency or intensity. Either way, storms of sorts happen high in Venus's atmosphere, invisible from the surface below, creating their own slow drama in the thick yellow clouds. Ancient astronomers knew Venus well. To the Babylonians, it was Ishtar, goddess of love and war. The Maya tracked its movements with remarkable precision, incorporating its cycles into their calendar. The Greeks called it Phosphorus when it appeared in the morning and Hesperus in the evening, before realizing these were the same object. The Romans named it Venus after their goddess of love and beauty, finding the bright, lovely light in the sky worthy of such a title. For much of human history, Venus was mysterious. Its clouds prevented anyone from seeing the surface, leading to speculation about what might lie beneath. Some imagined jungles and swamps, assuming Venus's clouds meant rain and water. Others proposed oceans covering the entire surface. Only in the 20th century, when spacecraft visited Venus and radar mapped its surface through the clouds, did humanity learn the truth about the hot, dry world that existed below that smooth, bright cloud deck. Soviet Venera spacecraft landed on Venus's surface in the 1970s and 80s, surviving the heat and pressure long enough to send back photos. These images showed a rocky landscape lit by the dim, orange light that filters through the clouds. Flat rocks like flagstones covered the ground. The sky glowed orange-yellow. The light diffused through the thick atmosphere. Everything looked still and silent, alien yet somehow familiar, like a strange desert at perpetual sunset. Venus has no moons, much like Mercury. It travels through space alone, wrapped in its clouds, keeping its secrets. There's something peaceful about imagining Venus drifting through the darkness of space, glowing softly with reflected sunlight, turning slowly backward as it makes its way around the sun year after year, era after era. Venus continues its patient backward rotation, taking its time, never hurrying, existing in its own unique state. Breathe slowly now, like Venus's rotation. Slow enough that one breath could last minutes if you wanted it to. Feel the weight of stillness settling over you, like Venus's thick atmosphere settling over its surface. Everything is constant. Everything is steady. Venus reminds us that different worlds can exist in different states, and each state has its own kind of peace, its own kind of stillness. Let yourself settle into that stillness now, as we drift toward the next world on our journey. Earth and Moon, our cosmic home. Now we arrive at Earth, the third planet from the Sun, our home in the vastness of space. From the perspective of the cosmos, Earth is a small, blue marble, glowing softly in the darkness, unique among all the planets we've discovered. It's the only world we know that harbors life, the only place where liquid water flows freely on the surface, the only planet where the atmosphere is rich with oxygen and clouds form from water vapor. This is our cradle, our sanctuary, the place where every human story has unfolded. Earth is just the right distance from the Sun, not too close like Mercury or Venus, where the heat would boil away the oceans, not too far like Mars and beyond, where the cold would freeze everything solid. Scientists call this the habitable zone, the region where conditions allow liquid water to exist, and Earth sits comfortably within this zone, bathed in the sun's warmth but not overwhelmed by it. Our planet is 70% covered by water. Oceans, vast and deep, hold most of this water, their blue depths concealing mountains taller than Everest and canyons deeper than the Grand Canyon. The Pacific Ocean alone covers nearly half the globe, a body of water so large that it contains more water than all other oceans combined. Waves roll across these oceans constantly, driven by winds and the gravitational pull of the moon, creating a rhythmic motion that has continued for billions of years. Imagine those waves, rolling and rolling, each one following the one before, each one cresting and breaking, foam and water in endless motion, soothing and constant. Earth's atmosphere is a thin shell of gases that surrounds our planet, a layer so thin that if Earth were the size of an apple, the atmosphere would be thinner than the apple's skin. Yet this thin layer sustains all life, filters the sun's harsh radiation, burns up meteors before they reach the ground, and creates the beautiful blue color we see when we look up at the sky. The atmosphere is mostly nitrogen and oxygen, gases that themselves have no color, but the way they scatter sunlight creates the blue dome above us during the day and the spectacular colors of sunrise and sunset. Earth rotates once every 24 hours, giving us our familiar cycle of day and night. This rotation is gradually slowing down just slightly due to the gravitational interaction with the moon. Billions of years ago, Earth rotated much faster, and a day was only about 6 hours long. Over the eons, the moon's gravity has acted like a gentle brake, slowing Earth's spin. This process continues today, adding about 1.7 milliseconds to the length of a day every century. The change is imperceptible in a human lifetime, but over deep time, it's significant. Our planet has seasons because Earth's axis is tilted 23.5 degrees relative to its orbit around the Sun. As Earth travels around the Sun, this tilt means that different parts of the planet receive more or less direct sunlight at different times of year. When the northern hemisphere tilts toward the Sun, it experiences summer, while the southern hemisphere experiences winter. 6 months later, the situation reverses. This tilt creates the beautiful cycle of seasons that so many living things depend upon. A rhythm of warmth and cold, growth and dormancy that has shaped life on Earth. Earth's interior is layered like an onion. At the center lies a solid iron core, incredibly hot, about the same temperature as the surface of the Sun, but kept solid by immense pressure. Around this solid core is a liquid iron outer core, where the movement of molten metal generates Earth's magnetic field. Above that lies the mantle, thick and hot, and flowing very slowly like thick honey, convection currents in the mantle driving the movement of Earth's tectonic plates. Finally, we have the thin crust, the solid rock we walk upon, itself divided into plates that drift around the surface at speeds of inches per year. This magnetic field is crucial. It extends far out into space, creating a protective bubble called the magnetosphere that deflects most of the charged particles streaming from the Sun. Without this shield, these particles would gradually strip away our atmosphere, as happened on Mars. But Earth's magnetic field keeps us safe, an invisible guardian that has protected our planet for billions of years. Sometimes, when these solar particles do interact with our atmosphere near the poles, they create the aurora, the northern and southern lights, beautiful curtains of green, red, and purple that dance across the polar skies. Now, let's turn our attention to the Moon, Earth's only natural satellite, our constant companion. The Moon is about 1/4 the size of Earth, unusually large for a moon relative to its planet. Most moons in the solar system are tiny compared to their planets, but the Moon is substantial enough that some astronomers consider the Earth-Moon system almost a double planet. The Moon formed about 4.5 billion years ago, shortly after Earth itself formed. The most widely accepted theory suggests that a Mars-sized object collided with the young Earth, and the debris from this massive impact eventually coalesced to form the Moon. If this happened, it was one of the most important collisions in history because the Moon has profoundly influenced Earth's development. The moon stabilizes Earth's axial tilt, preventing it from wobbling too much, which in turn stabilizes our climate over long periods. Without the moon, Earth might experience wild climate swings that would make the development of complex life much more difficult. The moon's gravity creates tides in Earth's oceans. As the moon orbits Earth, its gravitational pull creates a bulge in the ocean on the side facing the moon, and another bulge on the opposite side. As Earth rotates under these bulges, we experience high and low tides, the ocean rising and falling twice each day. This rhythmic rise and fall has shaped coastal ecosystems, influenced human settlement patterns, and served as a reliable timekeeper for countless generations. The sun also contributes to tides, and when the sun and moon align during new and full moons, we experience spring tides, where the tidal range is greatest. The moon always shows us the same face. This is because the moon is tidally locked to Earth, meaning its rotation period matches its orbital period. It takes 27.3 days for the moon to orbit Earth, and it takes exactly the same amount of time for the moon to rotate once on its axis. This synchronization means that one hemisphere of the moon always faces Earth, while the far side, sometimes incorrectly called the dark side, always faces away. Both sides receive sunlight as the moon orbits Earth. There's no permanently dark side, but there is a side we never see from Earth. The near side of the moon, the side we can see, has darker patches called Maria, Latin for seas, named by early astronomers who thought they might be bodies of water. They're actually vast plains of ancient volcanic basalt, formed billions of years ago when lava flowed across the moon's surface and filled in large impact basins. These dark areas contrast with the brighter highland regions, creating the pattern we see as the man in the moon, or various other shapes depending on cultural interpretation. The moon has no atmosphere, no air, no wind, no sound. When astronauts walked on the moon during the Apollo missions, they experienced absolute silence except for the sounds transmitted through their spacesuits. Their footprints pressed into the lunar dust remain there today, undisturbed by wind or rain, and they'll remain for millions of years until micrometeorite impacts gradually erase them. This permanence is both eerie and peaceful, a reminder of the unchanging nature of airless worlds. The lunar surface is covered in craters, scars from billions of years of impacts. Some of these craters are enormous. The South Polacan Basin on the far side is over 1,500 miles across and more than 5 miles deep, one of the largest impact structures in the solar system. Other craters are tiny, pockmarking the surface in endless profusion. Each crater tells a story of a cosmic collision, a piece of space debris that ended its journey by striking the moon. The moon is slowly drifting away from Earth, receding at about 1.5 inches per year. This happens because the tidal forces that the moon exerts on Earth also work in reverse. Earth's tidal bulge doesn't point exactly at the moon because of the friction of water moving across the ocean floor and the rotation of Earth. This offset means Earth's gravity pulls on the moon in a way that gradually boosts the moon's orbit, causing it to spiral slowly outward. Billions of years in the future, the moon will be much farther away, appearing smaller in our sky, and its stabilizing influence on Earth's tilt will be reduced. From the moon, Earth would appear nearly 4 times larger than the moon appears from Earth. Instead of being a bright circle in the sky, Earth would be a huge, colorful orb, mostly blue from the oceans, with white swirls of clouds, patches of green and brown from vegetation and land, and bright white caps at the poles from ice and snow. Earth would go through phases just as the moon does for us, waxing and waning as the sun illuminates different portions. But unlike the moon's rapid movement across our sky, Earth would appear nearly stationary in the lunar sky because of the moon's tidal locking, slowly changing phase but barely moving from its position. The moon influences more than just tides. It provides light on dark nights, the gentle silvery moonlight that has illuminated countless journeys and inspired endless poetry. It serves as a calendar, its phases marking out the months, 12 or 13 lunar cycles fitting into a solar year. Many cultures organize their calendars by the moon, and even today, many holidays are tied to lunar phases. The moon connects us to the cosmos, a visible, changing reminder that we live on a planet orbiting a star, part of a larger system. There's something deeply comforting about the moon's presence. It's been there throughout all of human history, watching over our planet, gently pulling at our oceans, stabilizing our climate, lighting our nights. Astronauts have visited and returned, leaving footprints and scientific equipment, but the moon remains largely untouched, a pristine natural satellite, our closest neighbor in space. As you rest here, imagine Earth and moon together, dancing their gravitational dance, locked in an embrace that has lasted for billions of years. The Earth turns, day becomes night, seasons change, tides rise and fall. The moon orbits, waxing and waning, showing us its constant face. This system, our home system, continues its ancient rhythms, reliable and steady, a pocket of stability and life in the vast darkness of space. Let this image settle over you. The blue Earth and gray moon, hanging together in the cosmic void, safe and enduring. Rest in this knowledge as we prepare to journey to our neighboring planet, the red world that has captured human imagination for centuries. Mars, the red wanderer. Moving outward from Earth, we cross a wide belt of asteroids and arrive at Mars, the fourth planet from the Sun, the red planet that has fascinated humanity since ancient times. Mars glows red in the night sky because of iron oxide, rust, covering much of its surface. This rusty dust gives Mars its distinctive color and makes it easy to spot from Earth, a reddish point of light that brightens and dims as its distance from Earth changes. Mars is about half the size of Earth, a small planet with a thin atmosphere, mostly carbon dioxide. This atmosphere is only about 1% as thick as Earth's atmosphere, providing very little protection from the sun's radiation and unable to retain much heat. Mars is cold, averaging about -80 degrees Fahrenheit, though temperatures can vary significantly depending on location and time of day. Near the equator on a summer day, temperatures might briefly reach 70 degrees, pleasant by Earth standards, but then plummet at night to well below freezing. The red planet has seasons just like Earth because Mars also has an axial tilt, about 25 degrees, very similar to Earth's tilt. This means as Mars orbits the Sun, different hemispheres receive more or less sunlight, creating seasonal changes. However, Mars's year is longer than Earth's, lasting 687 Earth days, so each season on Mars lasts nearly twice as long as Earth's seasons. Spring on Mars stretches through nearly 200 Earth days in the northern hemisphere, a slow, gradual awakening that would feel endless by our standards. Mars's surface is a varied landscape of ancient geology. Vast plains stretch for thousands of miles, some smooth and flat, others rough and cratered. Enormous volcanoes rise from these plains, silent and extinct, or at least dormant. Olympus Mons, the largest volcano in the solar system, towers over its surroundings, rising more than 13 miles high, nearly 3 times the height of Mount Everest. Its base is so wide, about the size of Arizona, that if you stood on its rim, the opposite side would be beyond the horizon. The slopes of Olympus Mons are gentle, rising only a few degrees, so climbing it would feel like walking up a very gradual hill that goes on and on and on. In the northern hemisphere, a vast plain called Vestidas Borealis covers nearly half of Mars's northern regions. This smooth plain sits lower than most of Mars's surface and has relatively few craters, suggesting it's younger than the heavily cratered southern highlands. Some scientists theorize this plain might once have been an ocean floor, billions of years ago when Mars might have had liquid water on its surface. If so, this ancient ocean would have been about the size of Earth's Indian Ocean, a vast body of water covering much of Mars's northern regions. The southern hemisphere of Mars is older and more heavily cratered, with highlands that rise several miles above the northern plains. This dramatic difference in elevation between north and south is called the Martian dichotomy, a fundamental feature of the planet that scientists are still working to fully explain. This division creates 2 distinct faces of Mars, the young smooth north and the ancient cratered south. Running along Mars's equator is Valles Marineris, a massive canyon system that dwarfs anything on Earth. This canyon is over 2,500 miles long, about 10 times the length of Earth's Grand Canyon, and in places reaches 4 miles deep. If it were on Earth, Valles Marineris would stretch across the entire United States from coast to coast. The canyon formed billions of years ago, possibly as Mars's crust split and pulled apart, creating this enormous scar that has remained ever since. Evidence suggests Mars once had abundant liquid water. Ancient river channels cut through the surface, their branching patterns clearly visible in images from orbit. Dried lake beds sit in craters, layers of sediment recording the gradual filling and drying of these ancient bodies of water. Vast outflow channels suggest sudden, catastrophic floods that released enormous volumes of water, carving deep channels in a matter of days or weeks. All of this water is gone now, either frozen into the polar ice caps and underground ice, or lost to space as Mars's atmosphere gradually thinned. Mars has 2 small moons, Phobos and Deimos, named after the sons of Ares, the Greek equivalent of Mars. Phobos is the larger of the 2 but still tiny, measuring only about 14 miles across. It orbits very close to Mars, completing an orbit in just 7.5 hours. From Mars's surface, Phobos would rise in the west and set in the east just over 4 hours later, appearing about half the size of our moon appears from Earth. Deimos is even smaller, only about 8 miles across, and orbits farther out, taking about 30 hours to complete one orbit. From Mars's surface, Deimos would appear only as a bright star, not a proper moon. Phobos is slowly spiraling inward toward Mars. Tidal forces are gradually pulling it closer, and in about 50 million years, it will either crash into Mars's surface or break apart from tidal stress, forming a ring around the planet. Until then, Phobos continues its rapid orbit, a small irregular moon hurtling around the red planet, a companion that won't last forever. The polar ice caps of Mars wax and wane with the seasons. These caps are made of water ice covered by a seasonal layer of frozen carbon dioxide, dry ice. In winter, this carbon dioxide freezes out of the atmosphere and deposits on the polar cap, causing it to grow larger and extend toward the equator. In summer, the carbon dioxide ice sublimes, turning directly from solid to gas, revealing the permanent water ice underneath and causing the cap to shrink. This annual cycle of growth and shrinkage happens with predictable regularity, a seasonal breathing of the planet as it exchanges material between its surface and atmosphere. Dust storms sometimes engulf Mars. Because the atmosphere is thin and gravity is weak, dust lifted by winds can rise high into the atmosphere and spread globally. Some dust storms grow so large they cover the entire planet, turning the sky from its usual butterscotch color to a uniform reddish haze. These global dust storms can last for months, gradually settling as the dust falls back to the surface. During these storms, the entire planet takes on a uniform, peaceful appearance from space, a smooth reddish globe obscured by suspended dust. The sky on Mars appears butterscotch or pinkish tan during the day because the rusty dust in the atmosphere scatters light differently than Earth's atmosphere does. At sunset and sunrise, however, the Martian sky turns blue around the sun, the opposite of Earth where the sun appears red or orange at these times. This happens because of how dust particles scatter light. The blue glow around the setting sun on Mars creates a serene, otherworldly scene, a reminder that familiar phenomena can manifest in beautifully different ways on other worlds. NASA's rovers have explored Mars's surface for years, sending back thousands of images. Spirit and Opportunity, the twin rovers, explored for years longer than their planned missions, with Opportunity functioning for nearly 15 years. Curiosity rover has been exploring since 2012, and Perseverance joined it in 2021. These robotic explorers have driven across Martian plains, climbed hills, descended into craters, and analyzed countless rocks and soil samples. Their tracks crisscross portions of Mars's surface, modern trails left by human technology on an ancient world. These rovers have found evidence that Mars was once much more hospitable. Rounded pebbles suggest ancient streams where flowing water smoothed rocks over time. Layers of sedimentary rock indicate lakes that persisted for thousands or millions of years. Chemical signatures in rocks suggest environments that might have been suitable for microbial life. Whether life ever actually existed on Mars remains unknown, but the planet clearly had the basic ingredients at some point in its past. The Martian day, called a sol, is only slightly longer than an Earth day, lasting 24 hours and 39 minutes. This similarity means that day-night cycles on Mars would feel familiar to humans. The sun would rise and set at familiar intervals, and you could almost keep Earth time on Mars with only minor adjustments. This similarity has practical implications for future Mars exploration, as human colonists wouldn't have to drastically adjust their circadian rhythms. Gravity on Mars is about 38% of Earth's gravity. This means if you weigh 150 pounds on Earth, you'd weigh only about 57 pounds on Mars. Walking would feel different, requiring less effort to move but also providing less traction. You could probably jump about 3 times higher than on Earth, though in a spacesuit, the extra mass might reduce this advantage. Everything would feel lighter, easier to lift and move, creating a sensation of reduced weight that would take time to adjust to. Mars has no global magnetic field like Earth does. Whatever magnetic field it once had disappeared billions of years ago, perhaps when the planet's core cooled and the dynamo effect that generates magnetic fields ceased. However, patches of ancient magnetized crust remain, particularly in the southern highlands, recording the magnetic field that once existed. These magnetic anomalies create localized magnetic fields, like fossil remnants of Mars's magnetic past. Without a strong magnetic field or thick atmosphere, Mars's surface is exposed to more radiation than Earth's surface. Solar radiation and cosmic rays reach the ground relatively unimpeded, creating a radiation environment that would be challenging for future human visitors. Underground habitats or habitats built into crater walls could provide natural shielding, and the planet itself offers protection if you build below the surface. The search for water on Mars continues. Radar observations suggest large deposits of ice beneath the surface, particularly at mid-latitudes. Some observations have identified what might be subsurface lakes or reservoirs. Ice definitely exists at the poles and in permanently shadowed craters. Seasonal dark streaks on slopes, called recurring slope lineae, might be evidence of salty water seeping from underground sources, though this interpretation is debated. Water, in frozen or perhaps liquid form, is definitely present on Mars, waiting beneath the rusty surface. Ancient Mars might have looked very different from the cold, dry planet we see today. Some models suggest it had a thicker atmosphere, warmer temperatures, and possibly an ocean in the northern lowlands. Rivers flowed, lakes persisted, perhaps even rainfall occurred. This wetter, warmer Mars would have been more Earth-like, a world where conditions might have been right for life to emerge. Whatever happened to change Mars from that world to the one we see today happened gradually, over hundreds of millions of years, as the atmosphere thinned and the water froze or escaped into space. Scientists study Mars partly because it might tell us about Earth's future or past, but also because it represents a path not taken, a planet that started similar to Earth but evolved differently. This divergence, this alternate possibility, makes Mars scientifically fascinating. It's close enough to be reachable, alien enough to be interesting, and similar enough to be comprehensible. Mars bridges the familiar and the strange. Imagine standing on Mars, looking up at a butterscotch sky. Two small moons visible during the night, one racing across the heavens, one barely moving. The sun smaller in the sky than on Earth, but still bright enough to illuminate the rust-colored landscape. Distant mountains on the horizon, their peaks catching the morning light. The absolute silence, even deeper than Mercury's, because you know this world once had wind and water and sound, but now rests quiet. Ancient riverbeds cutting through nearby hills, empty of water for billions of years. Everything still, everything patient. Mars waiting, as it has waited for eons, beneath its thin sky. Let yourself sink into that stillness. The ancient patience of Mars, a world that has changed but continues, that was once one thing and became another, teaching us that transformation is possible, that even planets evolve and adapt. Rest in the knowledge that Mars spins on, orbiting faithfully, its seasons changing, its ice caps growing and shrinking, its dust sometimes rising in great storms and then settling again. Everything in its time, everything in its rhythm. Let Mars's patient endurance wash over you as we prepare to journey outward toward the giant planets that dominate the outer solar system. Jupiter, the gentle giant. Beyond Mars, we cross another asteroid belt and enter the realm of the giant planets. Beginning with Jupiter, the largest planet in our solar system. Jupiter is so large that it could contain all the other planets combined with room to spare. Over 1,300 Earths could fit inside Jupiter's volume. Yet despite this immense size, Jupiter isn't solid like Earth or Mars. It's primarily made of gas, mostly hydrogen and helium, the same elements that make up the Sun. From space, Jupiter appears as bands of color, stripes of white, orange, brown, and red that circle the planet parallel to its equator. These bands are clouds at different altitudes and temperatures, organized by Jupiter's rapid rotation. Jupiter spins faster than any other planet, completing one rotation in just under 10 hours. This rapid spin causes Jupiter to bulge at the equator and flatten at the poles, giving it a noticeably oblate shape. The clouds are pulled into these bands by the Coriolis effect, similar to how Earth's rotation affects wind patterns, but much more pronounced because of Jupiter's size and rotation rate. The most famous feature on Jupiter is the Great Red Spot, a massive storm that has raged for at least 350 years, possibly much longer. This storm is larger than Earth, a swirling oval of clouds rotating counterclockwise, taking about 6 Earth days to complete one rotation. The Great Red Spot is an anticyclone, similar to a high-pressure system on Earth, with winds reaching speeds of several hundred miles per hour. Despite these violent winds, the storm moves slowly across Jupiter's face, drifting slightly in longitude, but maintaining its position in the southern hemisphere. The Great Red Spot is gradually shrinking. Observations over the past century show it's becoming smaller, though it remains enormous by any terrestrial standard. No one knows exactly why it's shrinking or whether it will eventually disappear, but for now it continues to rotate, a massive storm that has persisted longer than any nation on Earth has existed, longer than modern science itself. Other storms dot Jupiter's surface. White ovals, brown barges, smaller red spots, all rotating and evolving, some merging with others, some dissipating, new ones forming. Jupiter's atmosphere is never still, constantly churning. Yet when viewed from a distance, the planet appears serene, its cloud bands smooth and organized, the Great Red Spot a graceful oval, everything moving in slow celestial motion. Below the visible clouds, Jupiter's atmosphere extends down for thousands of miles. Pressure and temperature increase with depth until the hydrogen gas becomes liquid, and then, deeper still, becomes metallic hydrogen, a state where hydrogen acts like a liquid metal conducting electricity. This metallic hydrogen ocean is thought to extend from about 12,000 miles below the cloud tops down to the core region, comprising most of Jupiter's mass. This ocean of metallic hydrogen generates Jupiter's powerful magnetic field, the strongest of any planet, extending millions of miles into space. Jupiter's magnetosphere is enormous. It extends several million miles sunward and stretches all the way to Saturn's orbit behind Jupiter, a magnetic bubble larger than the Sun itself. This magnetosphere traps charged particles, creating intense radiation belts similar to but much stronger than Earth's Van Allen belts. Several of Jupiter's moons orbit within this radiation zone, bombarded constantly by energetic particles. Jupiter has at least 95 known moons, and more are discovered occasionally as telescope technology improves. These moons range from tiny irregular chunks of rock only a mile or two across to massive worlds larger than the planet Mercury. The 4 largest moons, called the Galilean moons because Galileo Galilei discovered them in 1610, are worlds unto themselves. Io, the innermost Galilean moon, is the most volcanically active body in the solar system. Tidal forces from Jupiter squeeze and flex Io constantly, generating enough heat to melt rock. Massive volcanoes erupt continuously, spewing sulfur and sulfur dioxide hundreds of miles into space. The surface of Io is constantly being repaved with new volcanic material, making it one of the youngest surfaces in the solar system. Despite this violence, Io orbits steadily, locked in its orbital resonance with Europa and Ganymede, its volcanism a kind of cosmic equilibrium, destruction and creation balanced. Europa, slightly smaller than our moon, has a surface of water ice, smooth and bright, crisscrossed with cracks and ridges. Beneath this frozen shell, scientists believe Europa holds a global ocean of liquid water, perhaps 60 miles deep, kept liquid by tidal heating from Jupiter. This subsurface ocean might contain twice as much water as all of Earth's oceans combined. Europa's ice shell shows features suggesting the ice sometimes cracks and refreezes, and warmer ice from below rises to the surface. Plumes of water vapor might occasionally erupt from this ocean through cracks in the ice, offering potential access to the ocean below without even drilling through the shell. If life exists elsewhere in our solar system, Europa is considered one of the most likely places. Its ocean is in contact with a rocky seafloor, allowing chemical interactions that could provide energy for life. The ocean has existed for billions of years, giving ample time for life to develop if the conditions are right. Europa orbits silently, its ice-covered surface bright and smooth, possibly harboring an entire ecosystem in the dark ocean beneath. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It has its own magnetic field, the only moon known to have one. Ganymede's surface is a mix of dark, heavily cratered terrain and lighter, grooved terrain, suggesting geological activity at some point in its past. Like Europa, Ganymede might also have a subsurface ocean, this one sandwiched between layers of ice at different pressures and temperatures. Callisto, the outermost Galilean moon, is heavily cratered, its surface ancient and unchanged for billions of years. Unlike Io and Europa, Callisto appears to have avoided significant geological activity. Its surface is dark and saturated with impact craters, each one a marker of cosmic collisions over the eons. Callisto might also have a subsurface ocean, though likely a smaller one than Europa's. This battered moon orbits at a safe distance from Jupiter's strongest radiation, ancient and patient. Jupiter's smaller moons fall into several groups. Some orbit close to Jupiter in nearly circular orbits and are probably captured asteroids. Others orbit far from Jupiter in irregular, highly elliptical orbits, sometimes even backwards relative to Jupiter's rotation. These distant, irregular moons were definitely captured by Jupiter's gravity at some point in the past, possibly pulled in when they wandered too close to the giant planet. Jupiter itself might not have a solid surface. The atmosphere gradually transitions from gas to liquid as you descend, with no clear boundary. If Jupiter has a core, it's deep in the center, possibly made of rock and ice, compressed to extreme densities by the weight of all the material above. But you couldn't land on Jupiter the way you could on Earth or Mars. You'd simply sink deeper and deeper into denser and denser atmosphere until the heat and pressure became overwhelming. From Jupiter, the Sun appears much smaller than from Earth, only about a fifth the apparent size. Jupiter receives only 4% as much sunlight per unit area as Earth does, which is why it's so cold. The temperature at Jupiter's cloud tops averages about -130 degrees Fahrenheit. Yet deep in the atmosphere, temperature increases, and at the level where pressure equals Earth's sea level pressure, the temperature is actually close to room temperature, around 50 degrees Fahrenheit. Below that, it gets hotter and hotter as you descend. Jupiter emits more energy than it receives from the Sun. This heat comes from leftover energy from Jupiter's formation and from helium slowly separating from hydrogen and sinking toward the core, releasing gravitational potential energy. This internal heat drives the powerful storms and atmospheric circulation we observe. Jupiter is like a slowly cooling ember, radiating heat into space, a process that will continue for billions of years. Ancient astronomers knew Jupiter well. To the Babylonians, it represented Marduk, their chief god. The Romans named it after Jupiter, their king of the gods, finding the bright, majestic presence in the sky worthy of their highest deity. Jupiter moves slowly across the sky relative to the stars, taking about 12 years to complete one orbit around the Sun, spending roughly a year in each zodiac constellation. Observing Jupiter through even a small telescope reveals its cloud bands and the Great Red Spot. The 4 Galilean moons are easily visible, appearing as small dots of light arranged in a line on either side of the planet. Their positions change from night to night as they orbit, sometimes disappearing behind Jupiter or passing in front of it, creating eclipses and transits. These moons perform an intricate dance, visible evidence of the celestial mechanics that govern all orbital motion. There's something comforting about Jupiter's massive presence in the solar system. Its powerful gravity has influenced the orbits of countless asteroids and comets, sometimes capturing them, sometimes flinging them into the outer solar system or into the Sun. Many scientists believe Jupiter acts as a kind of guardian for the inner solar system, its gravity preventing some comets and asteroids from reaching Earth. While this protective effect might be overstated in popular accounts, Jupiter certainly has influenced the architecture of our solar system in profound ways. Imagine floating in space near Jupiter, far enough to see the entire planet but close enough to make out details. The massive sphere fills your view, bands of clouds stretching across its face, the Great Red Spot slowly rotating, smaller storms scattered across both hemispheres. The planet rotates visibly, clouds flowing past, a 10-hour day in fast motion. Nearby, the Galilean moons orbit, tiny worlds themselves, each with its own character and mysteries. Behind you, the Sun appears small and distant. Ahead, Saturn and the outer planets wait in the darkness. And Jupiter, the giant, holds court, spinning rapidly, radiating warmth, its moons attending, everything in motion yet orderly. A cosmic clockwork operating for billions of years without pause. Rest in that massive presence. Let Jupiter's scale remind you of how vast the universe is, how small our concerns become when viewed from such perspectives. Everything continues, everything flows. Storms rage on Jupiter for centuries while we worry about moments. Let the patience of planets, the steadiness of orbits, the reliability of gravity and motion wash away whatever troubles occupied your mind. You are safe here, floating in thought through the solar system, observing without danger, learning without effort. Breathe slowly, like Jupiter's long year, taking your time, no rush, nowhere to be but here, Now, in this moment of cosmic peace, Saturn, the ringed wonder. Continuing outward, we come to Saturn, the sixth planet from the Sun, perhaps the most visually spectacular planet in our solar system. Saturn is famous for its rings, magnificent structures that encircle the planet like a celestial crown. These rings make Saturn instantly recognizable and have amazed observers since Galileo first glimpsed them through his telescope in 1610, though his early telescope wasn't powerful enough to reveal their true nature. He described Saturn as appearing to have ears or handles. Saturn is the second largest planet, smaller than Jupiter but still enormous by terrestrial standards. About 760 Earths could fit inside Saturn's volume. Like Jupiter, Saturn is a gas giant, composed primarily of hydrogen and helium. Saturn is less dense than Jupiter and, remarkably, less dense than water. If you could find an ocean large enough, Saturn would float. The planet rotates rapidly, completing one rotation in about 10.5 hours, slightly slower than Jupiter but still remarkably fast for such a large object. This rapid rotation causes Saturn to bulge at the equator even more noticeably than Jupiter. Saturn appears distinctly oblate, its equatorial diameter about 10% larger than its polar diameter. Saturn's atmosphere displays bands similar to Jupiter's, though they're less vivid and more subtle. Creamy yellows and pale golds dominate, with occasional light brown bands. The colors are muted compared to Jupiter's dramatic oranges and browns, giving Saturn a gentler, softer appearance. Despite this softer look, powerful storms do occur on Saturn. Occasionally, massive white storms erupt in the atmosphere, growing to encircle the entire planet before gradually dissipating over months. Every 30 years or so, a particularly large storm called a Great White Spot appears in Saturn's northern hemisphere. These storms are bright enough to be visible through amateur telescopes from Earth. The most recent appeared in 2010, growing to enormous size before gradually fading. These periodic great storms might be related to Saturn's seasons, appearing when the northern hemisphere experiences summer. Saturn has seasons because its axis is tilted about 27 degrees, similar to Earth's and Mars's tilts. However, Saturn's year lasts 29.5 Earth years, so each season lasts more than 7 years. The ring's appearance from Earth changes as Saturn orbits the Sun because we view them from different angles. Twice during Saturn's orbit, the rings appear edge-on from Earth and nearly disappear because they're so thin, only about 30 feet thick in most places despite being hundreds of thousands of miles wide. The rings are Saturn's most extraordinary feature. They extend outward from about 4,000 miles above Saturn's equator to over 175,000 miles, nearly halfway to Saturn's nearest major moon, Mimas. Despite their enormous extent, the rings are incredibly thin, thinner than a sheet of paper scaled to their width. They're composed of countless chunks of water ice, ranging from tiny grains to boulders the size of houses, all orbiting Saturn independently. These ice particles are surprisingly pure, reflecting sunlight brilliantly and giving the rings their bright appearance. Each particle follows its own orbit according to Kepler's laws, the laws of planetary motion that apply to all orbiting objects. The inner particles orbit faster, the outer particles slower, creating the concentric ring structure we observe. The rings aren't solid structures but countless individual objects, a disk of orbiting material surrounding the planet. The rings have structure. Rather than being uniform, They're divided into several distinct rings separated by gaps. The main rings, called a B and C, are visible from Earth through modest telescopes. The B ring is the brightest and most massive. The A ring is separated from the B ring by the Cassini division, a gap about 3,000 miles wide, visible from Earth as a dark band. This gap isn't empty but contains less material than the surrounding rings, created by orbital resonances with Saturn's moons. Moons play a crucial role in shaping the rings. Small moons orbit within the rings, called moonlets, their gravity creating propeller-shaped gaps. Larger moons orbit near the rings, their gravitational influence creating waves and gaps. Some moons act as shepherds, keeping ring particles in defined bands. The entire ring system is a dynamic, complex structure, constantly evolving under gravitational influences, billions of particles all interacting, creating patterns and structures through gravity alone. Where did Saturn's rings come from? Scientists aren't entirely certain. They might be remnants from Saturn's formation, material that never coalesced into moons. Or they might be the remains of a moon that ventured too close to Saturn and was torn apart by tidal forces. Or perhaps a comet or asteroid collided with a moon, shattering it into countless pieces. Whatever their origin, the rings are relatively young in geological terms, perhaps only a few 100 million years old. They won't last forever. Gradually, ring material is falling into Saturn, pulled in by magnetic forces and gravitational interactions. In perhaps 300 million years, the rings might be gone, and Saturn will be just another gas giant, less visually spectacular but still majestic. Saturn has at least 146 known moons, more than any other planet, though this number changes as new tiny moons are discovered. These moons range from tiny irregular objects only a mile or two across to Titan, the second largest moon in the solar system. Titan is extraordinary. It's the only moon with a thick atmosphere, denser than Earth's atmosphere, composed mostly of nitrogen with a small percentage of methane. The atmospheric pressure at Titan's surface is about 50% greater than Earth's sea level pressure. Thick orange clouds shroud Titan, making the surface invisible in ordinary visible light, but radar and infrared observations have revealed the world below. Titan has lakes and seas, but not of water. These are lakes of liquid methane and ethane, hydrocarbons that are gases on Earth but liquids on frigid Titan, where surface temperatures hover around -290 degrees Fahrenheit. These hydrocarbon lakes dot Titan's polar regions, some small, others large enough to be called seas. Ligeia Mare in the northern hemisphere is about the size of Lake Michigan and Lake Huron combined. These lakes have shorelines, beaches, even river channels feeding them. Titan has weather. Methane rain falls from the clouds, though not often. Rain might fall only once every few years or decades in any given location. But when it does, it can be torrential, creating temporary streams that flow across the landscape, carving channels before evaporating or soaking into the ground. Titan has a methane cycle similar to Earth's water cycle, with evaporation, cloud formation, precipitation, and runoff, all involving methane instead of water. The surface of Titan includes vast plains, sand dunes, mountains, and possible cryovolcanoes that erupt with water and ammonia instead of molten rock. The Huygens probe, which descended through Titan's atmosphere and landed on the surface in 2005, sent back images of a landscape with rounded cobbles, possibly smoothed by liquid flow. The orange sky filtered light down to the surface, which was dim, about the same as twilight on Earth. Titan might have a subsurface ocean of liquid water beneath its icy crust, kept liquid by tidal heating and the decay of radioactive elements. If so, this ocean would be sandwiched between layers of ice at different pressures. The possibility of both a surface hydrocarbon environment and a subsurface water ocean makes Titan one of the most interesting places in the solar system for astrobiology research. Enceladus, another of Saturn's moons, is much smaller than Titan but equally fascinating. This small icy moon, only about 310 miles in diameter, has massive geysers erupting from cracks near its south pole. These geysers shoot plumes of water vapor, ice particles, and organic molecules hundreds of miles into space. Much of this material falls back to Enceladus's surface, but some escapes and spreads out, forming one of Saturn's faint outer rings, the E ring. The source of these geysers is a subsurface ocean, confirmed by multiple observations. Enceladus, despite its small size and distance from the Sun, has liquid water beneath its ice shell, kept liquid by tidal heating from Saturn. The geysers provide direct samples of this ocean, ejected into space where spacecraft can fly through and analyze them. Scientists have detected complex organic molecules in these plumes, the building blocks of life, making Enceladus another prime target in the search for extraterrestrial life. Saturn's other moons each have their own character. Iapetus has one hemisphere much darker than the other, giving it a yin-yang appearance. Mimas has an enormous crater, Herschel, that makes it resemble the Death Star from Star Wars. Hyperion is irregularly shaped and tumbles chaotically in its orbit, unlike most moons that show the same face to their planet. Phoebe orbits backward and might be a captured object from the outer solar system. Saturn's interior is similar to Jupiter's, with liquid metallic hydrogen surrounding a possible rocky core, though less is known about Saturn's deep interior than Jupiter's. Saturn also emits more energy than it receives from the Sun, about twice as much, this excess heat coming from helium separation and gravitational contraction. Saturn's magnetic field is weaker than Jupiter's but still significant, creating a magnetosphere that interacts with the solar wind and traps charged particles. This magnetosphere extends to about 10 to 12 times Saturn's radius on the sunward side. The interaction between Saturn's magnetic field and the solar wind creates auroras at Saturn's poles, similar to Earth's northern and southern lights but occurring on a much larger scale. Ancient astronomers knew Saturn as the slowest of the visible planets, taking 29.5 years to orbit the Sun. To the Babylonians, it represented Ninurta, a god associated with agriculture. The Romans named it Saturn after their god of agriculture and time, fitting for the slowest moving planet visible to the naked eye. Saturn's slow movement made it seem patient and deliberate, qualities associated with old age and wisdom in many cultures. When viewed through a telescope, Saturn is breathtaking. The rings appear distinct and bright, especially when tilted at a good angle. On nights of steady seeing, when Earth's atmosphere is calm, you can observe the Cassini division, see the shadow of Saturn on the rings, and watch as moons drift across the face of the planet or disappear into its shadow. Saturn rewards patient observation, revealing new details the longer you watch. Imagine Saturn hanging in space, its rings spread wide, glowing in reflected sunlight. the planet itself pale gold, the rings brilliant white with faint shadows where gaps exist. The rings are tilted, showing their full magnificence. Tiny dots of moons scattered around, some within the rings, others farther out. Titan's orange atmosphere visible even from a distance. Behind Saturn, the Sun appears small, and the familiar inner planets are lost in its glare. Around you, the stars shine steadily, untwinking in the absence of atmosphere, and Saturn slowly rotates, its 10-hour day quick enough to see clouds moving, the rings remaining steady, patient, beautiful. Let Saturn's beauty settle into your awareness. Its rings, unlikely structures that exist only briefly in cosmic time, remind us that beauty is often temporary, making it more precious. Let the complexity of its moons, each a world, each with stories to tell, remind you that richness and detail exist everywhere if we look closely enough. Breathe in the patience of Saturn's long year. Breathe out any remaining tension. You are drifting peacefully through the outer solar system, where planets take decades to orbit, where time moves differently, where everything is vast and cold and beautiful and patient. Rest in that coldness, that distance, that serene alien landscape of ice and hydrocarbon, where moons erupt with water and lakes hold liquid methane, where reality is stranger and more wonderful than simple imagining. Let yourself drift deeper into relaxation as we journey to the ice giants of the outer reaches. Uranus and Neptune, the ice giants. Beyond Saturn's orbit, we enter the realm of the ice giants, planets that mark the outer edge of the main solar system. First comes Uranus, the seventh planet from the Sun, a world that rotates on its side and exhibits a subtle, cyan blue color. Uranus is about 4 times the diameter of Earth and about 14.5 times Earth's mass, large enough to be called a giant planet, but significantly smaller than Jupiter and Saturn. The most unusual feature of Uranus is its axial tilt, an extreme 98 degrees, meaning Uranus essentially rolls along its orbital path rather than spinning like atop the way most planets do. Scientists aren't certain why Uranus tilts so severely. The most likely explanation is that early in the solar system's history, a massive collision with an Earth-sized object knocked Uranus onto its side. Whatever the cause, this extreme tilt creates the strangest seasons in the solar system. During Uranus's 84-year orbit around the Sun, each pole points almost directly at the Sun for about 21 years, creating an extreme summer where one hemisphere experiences continuous daylight while the other experiences continuous darkness. Then, as Uranus continues its orbit, the Sun appears to rise higher and lower in the sky at mid-latitudes, and eventually the opposite pole tilts toward the Sun. The equinox periods, when the Sun appears over Uranus's equator, create more moderate conditions. These extreme seasons would make for strange experiences if you could observe them from Uranus's surface. Uranus appears cyan blue because of methane in its upper atmosphere. Methane absorbs red light but reflects blue and green light, giving Uranus its distinctive color. The atmosphere is mostly hydrogen and helium like Jupiter and Saturn, but with a higher proportion of ices, substances like water, ammonia, and methane, which is why Uranus is classified as an ice giant rather than a gas giant. The atmosphere of Uranus appears remarkably bland when viewed from a distance. Unlike Jupiter's dramatic bands and swirls or Saturn's occasional massive storms, Uranus shows little visible cloud structure. The planet appears as a nearly featureless cyan disk. However, when viewed in infrared or other wavelengths, and when the atmosphere is monitored over time, subtle features do appear. Occasionally, bright clouds pop up in Uranus's atmosphere, marking regions where methane ice crystals form at high altitude. These clouds are tracked to measure wind speeds, which can reach several hundred miles per hour. Uranus's lack of dramatic atmospheric features is somewhat mysterious. It receives much less solar energy than Jupiter or Saturn because of its distance from the Sun, which might partly explain the calmer appearance. But Uranus also emits very little internal heat, unlike the other giant planets. While Jupiter and Saturn radiate about twice as much energy as they receive from the Sun, Uranus emits almost no excess heat. Scientists aren't sure why. This lack of internal heat might explain the calm atmosphere, as there's less energy to drive storms and atmospheric circulation. The interior structure of Uranus is thought to consist of a small rocky core surrounded by a mantle of ices, water, ammonia, and methane, in high-pressure forms that don't exist on Earth. Above this mantle lies the atmosphere, gradually transitioning from liquid to gas with increasing altitude. The high-pressure ice mantle might have exotic properties, possibly with superionic states where water molecules form a solid lattice while hydrogen ions flow freely through it, conducting electricity. Uranus has a magnetic field, but unlike most planets where the magnetic field axis is roughly aligned with the rotation axis, Uranus's magnetic field is tilted about 60 degrees from its rotation axis and offset from the planet's center. This creates a lopsided, complex magnetic field that tumbles as the planet rotates. The magnetosphere, the region of space dominated by Uranus's magnetic field, is therefore highly dynamic, unlike the more stable magnetospheres of other planets. Uranus has 27 known moons, all named after characters from the works of William Shakespeare and Alexander Pope, a departure from the tradition of using mythological names. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, were all discovered before the space age. The Voyager 2 spacecraft revealed 12 additional small moons when it flew past Uranus in 1986, and subsequent ground-based observations discovered more. Miranda, the smallest of the 5 major moons, has one of the most bizarre surfaces in the solar system. It shows enormous variations in terrain, from rolling cratered plains to regions of parallel grooves and ridges, meeting at sharp boundaries called coronae. One cliff face, Verona Rupes, is estimated to be about 3 miles high, 10 times the depth of the Grand Canyon. Miranda looks like it was taken apart and reassembled incorrectly. Scientists theorize that Miranda might have been shattered by an impact and then gravitationally reassembled, with different pieces settling into odd configurations. The other major moons of Uranus also show interesting features. Ariel has the brightest surface with relatively few craters, suggesting geological activity resurfaced parts of it relatively recently. Umbriel is the darkest, heavily cratered and ancient. Titania and Oberon are both large, heavily cratered, and appear geologically inactive for billions of years. All these moons orbit in Uranus's equatorial plane, meaning their orbits are perpendicular to Uranus's orbit around the Sun, another consequence of Uranus's extreme tilt. Uranus has rings, though they're much darker and harder to see than Saturn's magnificent ring system. 13 rings are known, narrow and dark, composed of dark particles that might be radiation-darkened ice. These rings were discovered in 1977 when Uranus passed in front of a star, and the star's light flickered on and off as the rings blocked it. The Voyager 2 flyby imaged the rings directly, revealing their dark, narrow structure. From Uranus, the Sun appears tiny, over 360 times dimmer than we see it from Earth. Uranus receives only about 1/400th the solar energy per unit area that Earth receives. The solar system's inner planets would be invisible to the naked eye from Uranus, lost in the Sun's glare or simply too faint to see. The dominant feature in Uranus's sky would be its moons, several appearing larger than our moon appears from Earth, drifting across the pale blue sky. If you could descend into Uranus's atmosphere, you'd pass through layers of haze and clouds, the pressure and temperature gradually increasing. Eventually, you'd reach a region where the atmosphere becomes so dense it's more like an ocean, supercritical fluid that's neither truly gas nor truly liquid. Deeper still, exotic ices at high pressure and temperature. The descent would be dark, the weak sunlight fading to black as you sank deeper, pressure mounting, until you reached regions where no human technology could survive. Uranus keeps its deep interior secret, accessible only to theoretical models and speculation. Beyond Uranus lies Neptune, the 8th planet and the outermost major planet in our solar system. Neptune is similar in size to Uranus, slightly smaller in diameter but slightly more massive, with a similar composition of ices, rock, and atmosphere. Neptune also appears blue, a deeper, richer blue than Uranus because of slightly different atmospheric composition or distribution of methane. Unlike Uranus with its bland appearance, Neptune's atmosphere is dynamic and active. White clouds of methane ice crystals drift in the atmosphere, some moving at different speeds than the planet's rotation, driven by atmospheric winds. Dark spots occasionally appear, massive storm systems similar to Jupiter's Great Red Spot. The most famous was the Great Dark Spot, observed by Voyager 2 in 1989, an Earth-sized storm system in Neptune's southern hemisphere. This storm had disappeared by the time the Hubble Space Telescope observed Neptune a few years later, showing that Neptune storms can form and dissipate on timescales of years. Neptune's atmosphere shows faster winds than any other planet in the solar system, with wind speeds reaching over 1,200 miles per hour. These winds blow in the opposite direction to Neptune's rotation in some latitudes, creating a complex pattern of wind bands. Why Neptune, so far from the Sun and receiving so little solar energy, has such a dynamic atmosphere is something of a mystery. The answer lies in Neptune's internal heat. Unlike Uranus, Neptune radiates significantly more energy than it receives from the Sun, about 2.6 times as much, similar to Jupiter and Saturn. This internal heat drives powerful atmospheric circulation, creating the winds and storms we observe. Neptune's axis is tilted 28 degrees, similar to Earth's tilt, creating seasons, though each season lasts over 40 years because Neptune takes 165 years to orbit the Sun. Neptune hasn't completed a full orbit since its discovery in 1846. It completed its first observed full orbit in July 2011, 1 Neptunian year after discovery. Neptune was the first planet discovered through mathematical prediction rather than direct observation. Astronomers noticed that Uranus's orbit didn't quite match predictions, as if an unseen planet's gravity was pulling on it. Mathematicians in France and England independently calculated where this unknown planet should be, and when astronomers pointed their telescopes to that region of sky, there was Neptune almost exactly where predicted. This discovery was a triumph of mathematical astronomy and gravitational theory, demonstrating that Newton's laws could predict planetary positions with remarkable accuracy. Neptune's interior is thought to be similar to Uranus's, with a small rocky core, a mantle of high-pressure ices, and an atmosphere gradually transitioning from gas to liquid. Like Uranus, Neptune's magnetic field is tilted and offset from the planet's center, creating a complex, asymmetric magnetosphere. However, Neptune's magnetic field is even more offset and tilted than Uranus's, about 47 degrees from the rotation axis. Neptune has 14 known moons, the largest of which is Triton, a captured object that originally formed elsewhere in the solar system. Triton is unusual because it orbits Neptune backward, opposite to Neptune's rotation, called a retrograde orbit. This retrograde orbit proves Triton wasn't formed alongside Neptune but was captured by Neptune's gravity at some point in the past. Triton's orbit is slowly decaying, pulled inward by tidal forces, and in perhaps 3.6 billion years, it will either crash into Neptune or be torn apart by tidal forces to form a ring system. Triton is a fascinating world. It's geologically active despite its frigid surface temperature of -391 degrees Fahrenheit, the coldest surface temperature measured anywhere in the solar system. Voyager 2 observed geysers on Triton, plumes of nitrogen gas and dark dust particles erupting from beneath the surface and rising several miles into the thin atmosphere before being blown downwind, creating dark streaks on Triton's surface. These geysers show that even in the extreme cold of the outer solar system, geological activity can occur. Triton's surface is a mix of frozen nitrogen, water ice, carbon dioxide ice, and methane ice, creating a varied terrain of craters, smooth plains, and cantaloupe terrain, odd dimpled regions unique to Triton. Some regions are very young, with few craters, suggesting resurfacing happened relatively recently. Triton might have a subsurface ocean, kept liquid despite the extreme cold by tidal heating when Triton's orbit was more elliptical in the past, and possibly by radiogenic heating from the decay of radioactive elements. Triton likely originated in the Kuiper Belt, the region of icy objects beyond Neptune. It might have been a dwarf planet similar to Pluto before Neptune captured it. This capture would have been a dramatic event, possibly involving a collision with another moon or a three-body interaction that slowed Triton enough for Neptune's gravity to capture it. Once captured, tidal forces circularized Triton's orbit and probably destroyed any other large moons Neptune had at the time. Neptune's other moons are much smaller. Proteus, the second largest, is an irregular chunk of rock and ice, heavily cratered and dark. The remaining moons are even smaller, most discovered by Voyager 2 or recent ground-based observations. Like Uranus's moons, Neptune's moons orbit in various inclinations and distances, some regular moons in nearly circular orbits, others irregular captured objects in eccentric orbits. Neptune has rings, though like Uranus's rings, they're dark and faint. 5 main rings have been identified, named after astronomers who contributed to Neptune's discovery or study. These rings are clumpy in places, with some regions containing more material than others. The outermost ring, the Adam's ring, has 5 bright arcs where material has concentrated, though scientists don't fully understand why material would concentrate in arcs rather than spreading evenly around the orbit. From Neptune, the solar system appears very different than from Earth's perspective. The sun is tiny, a bright star that provides little warmth, over 900 times dimmer than we see it from Earth. The inner planets are invisible, lost in the sun's glare, or simply too small and distant to see. Uranus might be visible as a faint star if you knew where to look. The sky is dominated by stars, thousands visible even without magnification because there's no air to scatter light or create a bright sky. Triton would be spectacular, appearing much larger than our moon, a bright object dominating the night sky with its peculiar backward motion. If you could exist in Neptune's environment, floating in the upper atmosphere, you'd experience winds more powerful than anywhere else in the solar system, cold beyond human experience, pressure that would crush any spacecraft. Yet there's something peaceful about imagining this distant, blue world, spinning in the outer darkness, its moons orbiting, its rings silently circling, its atmosphere churning with storms that have lasted years or decades, all so far from the warmth of the sun that Neptune might as well be floating in interstellar space. Neptune represents the edge of the main solar system, the last of the giant planets, the final major world before the vast outer darkness. The ice giants, Uranus and Neptune, are less well known than Jupiter and Saturn, visited only once each by a spacecraft, Voyager 2, in the 1980s. Much about them remains mysterious. Their interiors, their magnetic fields, their moons, their rings, all hold secrets that await future missions to uncover. They orbit in the cold outer solar system, taking decades or centuries to complete one orbit, patient and distant, blue worlds of ice and wind, existing in the dim light at the edge of the sun's domain. Let the coldness of these distant worlds wash over you. Not an uncomfortable cold, but the cold of distance, of perspective, of remoteness from everyday concerns. Uranus and Neptune don't worry about the inner planets. They don't concern themselves with Earth's frantic pace or Mars's lost atmosphere. They simply exist, slowly orbiting, their long years passing, their moons steadily circling, their atmospheres churning in slow motion. Time moves differently here. Perspective shifts. What seems urgent from Earth becomes trivial from Neptune. What seems important today becomes irrelevant across the span of Uranus's 84-year orbit. Let this sense of cosmic time, of vast distance, of patient planetary motion settle into your awareness. Breathe slowly, matching the pace of these distant worlds. Feel yourself drifting deeper into relaxation, deeper into sleep, as we journey to the final frontier, the realm beyond Neptune where small worlds orbit in the cold darkness at the edge of our solar system. Beyond Neptune, the outer reaches. Beyond Neptune's orbit lies a vast region of space populated by small icy worlds, remnants from the solar system's formation. This is the Kuiper Belt, extending from Neptune's orbit at about 30 astronomical units from the Sun to perhaps 50 astronomical units, where 1 astronomical unit is the distance from Earth to the Sun. The Kuiper Belt is similar to the asteroid belt between Mars and Jupiter, but it's much larger and contains objects made mostly of frozen volatiles, ices of methane, ammonia, and water. Pluto resides in the Kuiper Belt. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006 when the International Astronomical Union established formal definitions for planetary categories. This reclassification sparked controversy and debate, but it reflected the discovery of many other similar objects in the outer solar system, making Pluto one of many rather than unique. Pluto is small, smaller than Earth's moon, with a diameter of only about 1,430 miles. Its surface is a mix of nitrogen ice, methane ice, water ice, and dark organic compounds, creating a varied landscape that surprised scientists when the New Horizons spacecraft flew past in July 2015. Images from New Horizons revealed a complex world with mountains of water ice rising several miles high, vast plains of nitrogen ice showing convection patterns, possible cryovolcanoes, and a thin atmosphere that extends far into space. The most striking feature on Pluto is a heart-shaped region called Tombaugh Regio, named after Clyde Tombaugh, who discovered Pluto in 1930. The left side of this heart, Sputnik Planitia, is a vast plain of nitrogen ice, smooth and relatively crater-free, indicating it's geologically young, perhaps less than 10 million years old. The nitrogen ice appears to be convecting, slowly turning over in cells like a lava lamp, driven by heat from Pluto's interior. This geological activity on such a small, distant world surprised scientists and revealed that the outer solar system is more dynamic than previously thought. Pluto has 5 known moons. Charon, the largest, is so large relative to Pluto that some astronomers consider Pluto-Charon a double dwarf planet rather than a planet and moon. Charon is about half Pluto's diameter and about 1/8 its mass. The two objects orbit a point between them, called the barycenter, which lies outside Pluto's surface. They're tidally locked to each other, meaning they always show the same face to each other, rotating and orbiting in perfect synchronization. Charon's surface is different from Pluto's, dominated by water ice rather than nitrogen ice, and darker. A dark polar cap on Charon might be made of organic compounds called tholins, created when methane from Pluto's atmosphere escapes, gets captured by Charon, and is processed by ultraviolet light and cosmic rays. Charon also shows signs of past geological activity, with canyons and ridges suggesting the surface once expanded and cracked. Pluto's 4 smaller moons, Styx, Nix, Kerberos, and Hydra, are much tinier, irregularly shaped chunks of ice and rock, probably fragments from an ancient collision. They orbit Pluto and Charon in the same plane, tumbling chaotically rather than showing one face to Pluto like normal moons do. These small moons might be difficult to visit in the future because their chaotic tumbling makes their orbits less predictable on short timescales. Pluto takes 248 years to orbit the Sun in an elliptical orbit that's tilted 17 degrees relative to most planets' orbital planes. At perihelion, its closest approach to the Sun, Pluto comes inside Neptune's orbit, though the orbits are arranged so the two worlds never collide. At aphelion, Pluto recedes to nearly 50 astronomical units from the Sun. Currently, Pluto is moving away from perihelion, which it passed in 1989, meaning it's gradually getting colder and more distant. Pluto has an atmosphere, a thin haze of nitrogen with traces of methane and carbon monoxide, that extends far above the surface and slowly escapes into space. This atmosphere freezes out and falls to the surface when Pluto is far from the Sun, then sublimates and expands when Pluto approaches perihelion and warms slightly. New Horizons observed complex haze layers in Pluto's atmosphere, possibly created by photochemical reactions driven by sunlight acting on the atmospheric gases. Many other objects orbit in the Kuiper belt alongside Pluto. Eris, slightly smaller than Pluto but more massive, orbits beyond Pluto in a highly elliptical orbit. Its discovery in 2005 prompted the reclassification of Pluto because Eris is similar in size and nature to Pluto, raising the question of whether Eris should also be called a planet. Rather than adding Eris and potentially dozens of other objects as planets, astronomers decided to create the dwarf planet category. Makemake and Haumea are other large Kuiper belt objects, both smaller than Pluto but substantial worlds in their own right. Makemake appears to have a surface of frozen methane and nitrogen, giving it a reddish color. Haumea is unusual because it spins very rapidly, completing one rotation in less than 4 hours, giving it an elongated, ellipsoidal shape. Haumea also has 2 small moons and possibly a ring system, making it one of the most interesting objects in the outer solar system. Beyond the Kuiper belt lies the scattered disk, a region of objects with highly elliptical and inclined orbits, scattered outward by gravitational interactions with Neptune. Objects in the scattered disk have orbits that take them far beyond the Kuiper belt at aphelion, sometimes hundreds of astronomical units from the Sun, before swinging back in to closer distances. These objects are thought to be the source of many short-period comets that occasionally enter the inner solar system. Sedna is an object with one of the most distant orbits known. At perihelion, it comes about 76 astronomical units from the Sun, farther than most Kuiper belt objects. At aphelion, it recedes to about 937 astronomical units, taking about 11,400 years to complete one orbit. Sedna's orbit is so distant and elliptical that some astronomers think it might have been perturbed by a passing star billions of years ago, or could indicate the presence of an undiscovered massive planet in the outer solar system. The hypothetical Planet 9, also called Planet X, is a proposed massive planet orbiting far beyond Neptune, perhaps 200 to 800 astronomical units from the Sun. Its existence has been proposed based on unusual clustering of orbits of several distant objects, which might be explained by the gravitational influence of an unseen planet. Searches for Planet 9 are ongoing, but nothing has been definitively detected yet. If it exists, it would be several times Earth's mass and take 10 to 20,000 years to orbit the Sun. Beyond the scattered disk at enormous distances lies the Oort cloud, a theoretical spherical shell of icy objects surrounding the solar system. The Oort cloud is thought to extend from about 2,000 astronomical units to perhaps 100,000 astronomical units from the Sun, roughly halfway to the nearest star. Objects in the Oort cloud orbit so slowly and at such distances that they're barely bound to the Sun. Passing stars can perturb these objects, sending some into the inner solar system where they become long-period comets. No spacecraft has reached the Oort cloud, and none will for many centuries at current technology levels. Voyager 1 and 2, humanity's most distant spacecraft, have left the heliosphere, the region of space dominated by the solar wind, and are now in interstellar space, but they're still far from the Oort cloud and will take thousands of years to reach its inner edge. These spacecraft will eventually fall silent as their power sources decay, drifting through interstellar space essentially forever, carrying messages from humanity into the cosmic void. The outer solar system is a realm of cold and darkness, but also of surprising activity and diversity. Pluto has an active surface with nitrogen ice plains and possible cryovolcanoes. Eris orbits far beyond, a twin to Pluto in size and nature. Countless smaller objects drift in the darkness, remnants from the solar system's birth, pristine samples of the material from which planets formed. These objects will likely never be visited by humans, but robotic missions may one day explore more of them, revealing the secrets of the outer frontier. From these distant worlds, The sun appears as a bright star, brighter than any other star but clearly just a star, not the blazing orb we know from Earth. The planets are invisible, mere points of light if they can be seen at all. The solar system seems small and compact, a tiny cluster of orbits around that bright star, surrounded by endless empty space filled with faint stars stretching to infinity. This is the perspective from the edge, where the solar system fades into the interstellar medium, where the sun's influence weakens, where the cosmic cold truly sets in. The journey through the outer reaches reveals the solar system's extent and the incredible distances involved. Earth seems even smaller and more precious from this perspective, a warm oasis in a vast cold desert, the only place in this enormous system where life flourishes, where consciousness has arisen to contemplate the cosmos. The outer solar system is beautiful in its desolation, important in its science, fascinating in its mysteries, but ultimately alien and inhospitable, emphasizing how special our small blue world truly is. Let the vastness wash over you. The Kuiper Belt, scattered disk, Oort cloud, all stretching outward into the darkness. Billions of icy bodies, most unnamed, most unknown, drifting in orbits that take centuries or millennia, patient beyond human comprehension. Some will eventually fall into the inner solar system as comets, but most will remain in the outer darkness forever, slowly orbiting the distant sun, monuments to the solar system's formation, keepers of ancient ice, witnesses to billions of years of cosmic history. Breathe in the darkness of deep space. Breathe out the last tensions of your day. Feel yourself floating among these distant objects, weightless, timeless, at peace in the cosmic void. Nothing urgent exists here. Nothing demands immediate attention. Time stretches on endlessly. Years pass like moments, centuries like heartbeats. You are safe in this mental journey, exploring without danger, learning without effort, drifting without destination. Let your mind relax completely as we begin our return journey, not flying back through the planets, but simply transitioning gently toward the deepest rest and the welcoming embrace of sleep. As we complete our journey through the solar system, from the scorched surface of Mercury to the frozen darkness of the Kuiper Belt, take a moment to appreciate the magnificent cosmic neighborhood we inhabit. 8 major planets, countless moons, asteroids, comets, and dwarf planets, all bound together by gravity, all orbiting our sun, all part of one interconnected system that has existed for 4.5 billion years and will continue for billions more. Each world we've visited has its own character, its own beauty, its own mysteries. Mercury with its ancient craters and extreme temperatures. Venus with its thick clouds and backward rotation. Earth and Moon, our home and companion. Mars with its rusty deserts and lost rivers. Jupiter, the giant with its great red spot and family of diverse moons. Saturn with its magnificent rings and hydrocarbon lakes on Titan. Uranus rolling on its side through its long orbit. Neptune with its powerful winds and captured moon Triton. And beyond, the realm of small icy worlds, remnants from creation, drifting in the outer darkness. These worlds continue their ancient dance even as you rest here. Jupiter spins rapidly, completing another rotation every 10 hours. Saturn's rings orbit, billions of ice particles each following its own path. Mars's polar ice caps slowly change with the seasons. Venus's thick atmosphere circulates, carrying clouds around the planet in 4-day cycles. Mercury slowly turns its cratered face, half in blazing sunlight, half in freezing darkness. Neptune's storms rage on, winds howling through the frigid atmosphere. Uranus rolls along its orbit, its extreme tilt creating seasons unlike anywhere else. Pluto and Charon orbit their common center of mass, locked together for billions of years. The cosmic clockwork continues, reliable and eternal. You are part of this system. The atoms in your body were forged in stars that existed before our sun, scattered through space when those stars died, then gathered into the molecular cloud that collapsed to form our solar system. The calcium in your bones, the iron in your blood, the oxygen you breathe, all came from stellar nucleosynthesis, from the hearts of ancient stars. You are literally made of stardust, connected to the cosmos in the most fundamental way possible. As you lie here, Earth carries you through space at about 67,000 miles per hour as it orbits the sun. You don't feel this motion because everything around you moves together. But you are traveling through space right now, on a planet that spins and orbits and moves through the galaxy, part of the cosmic dance, part of the great cycle of matter and energy that is the universe. Let this perspective shift your awareness. The concerns that seemed important earlier today shrink to insignificance against the backdrop of billions of years and trillions of miles. The anxieties that kept your mind active fade when you remember that Earth has been orbiting for over 4 billion years, that the sun will continue shining for 5 billion more, that the universe operates on timescales that make human troubles seem momentary, fleeting, insignificant. Take a deep, slow breath. Feel your chest rise and fall. This breathing is powered by oxygen from Earth's atmosphere, oxygen created by plants and algae through photosynthesis, using energy from the sun, energy that originated in the nuclear fusion happening in the sun's core. Every breath connects you to the sun, to Earth's biosphere, to the flow of energy that sustains all life. As you exhale, release any remaining tension. Let your shoulders sink deeper into the surface beneath you. Let your arms rest heavily, completely relaxed. Your legs feel pleasantly weighted, settled, still. Your face is smooth, your jaw relaxed, your eyes gently closed. You are supported, safe, comfortable. Your mind has traveled far tonight, from the inner solar system to the outer reaches, learning facts about planets and moons, but not in a way that required effort or concentration. The information has washed over you like gentle waves, some facts sticking, others flowing past, all contributing to a sense of peaceful exploration and cosmic perspective. Now it's time to let even this gentle focus fade. The planets will continue without your attention. Jupiter doesn't need you to think about its great red spot for the storm to keep spinning. Saturn's rings will orbit whether you visualize them or not. The universe carries on, and you can rest knowing that everything is as it should be, operating according to natural law, following paths set billions of years ago. Feel yourself sinking deeper into relaxation with each breath. Your body is heavy, comfortable, relaxed. Your mind is quiet, peaceful, empty of urgent thoughts. You might notice sounds around you, distant and unimportant, like observations of a far-off world, interesting but not requiring any response. These sounds are part of your environment, neither good nor bad, just present, and you can let them flow past without grabbing your attention. If thoughts arise, let them drift by like planets in a telescope's field of view, passing through awareness and then moving on, not holding your focus. You don't need to think about tomorrow or yesterday. You don't need to plan or worry or analyze. Right now, in this moment, your only purpose is to rest, to let sleep come naturally, to drift into the peaceful darkness like a spacecraft floating in the void between stars. Imagine yourself floating in space, but safely, comfortably, in a small bubble of warmth and air. Around you, the stars shine steadily, thousands of points of light against the perfect black. No sound reaches you, no urgency touches you. You float in serene silence, held by nothing, supported by everything, at peace in the cosmic ocean. This feeling of floating, of weightlessness, of perfect calm. This is available to you anytime you need it. Whenever stress or anxiety rises, you can remember this journey through the solar system. Remember the vastness of space and time. Remember that you are made of stardust floating on a small blue world that circles an ordinary star in an ordinary galaxy among billions of galaxies. This perspective can shrink problems to their true size and restore a sense of calm proportion. But for now, don't think about using this technique or remembering anything. For now, simply let yourself float deeper into rest. Your breathing is slow and regular, requiring no attention. Your body knows how to breathe while you sleep. Your heart knows how to beat. All the automatic processes of life continue without your conscious direction. You can trust your body to take care of itself while your conscious mind rests completely. The solar system continues its ancient patterns. Earth turns, bringing day and night. The moon orbits, pulling at the oceans, creating tides that have risen and fallen for billions of years. Mars's polar caps wax and wane with the seasons. Jupiter's moons orbit in mathematical precision. Saturn's rings slowly evolve, particles colliding and spreading, gaps opening and closing. Uranus rolls on its side. Neptune's atmosphere churns. Pluto and Charon dance together in the outer darkness. Everything continues, everything flows, and you can rest in this knowledge. You are safe. You are comfortable. You are exactly where you should be. There is nothing you need to do, nothing you need to think about, nothing requiring your attention. This is your time to rest, to sleep, to let consciousness fade into the peaceful darkness that is both the space between stars and the space between thoughts. Let go of the day. Let go of plans for tomorrow. Let go of any grip you still have on waking awareness. Sleep is here, gentle and welcoming, ready to embrace you. You don't need to force sleep or try to sleep or think about sleeping. Simply let it happen naturally, the way planets orbit naturally, the way gravity works naturally, the way the universe unfolds according to its own laws. Your eyelids are heavy, already closed, relaxed. Your breathing is slow and deep, peaceful and regular. Your body is still, settled, comfortable. Your mind is quiet, empty, at rest. Everything is perfect just as it is. You are drifting now, floating between waking and sleeping, that pleasant space where thoughts become dreams and awareness softens into rest. The planets are still there, orbiting in the darkness, but they're fading from your awareness now, becoming distant, unimportant, like memories from long ago. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and the distant worlds beyond, all fading, all releasing you, all giving you permission to stop thinking and start sleeping. Darkness is peaceful. Silence is restful. Stillness is comfortable. You are sinking deeper now, deeper into the bed beneath you, deeper into relaxation, deeper into sleep. With each breath, you sink deeper. With each moment, you become more relaxed. With each thought that fades, you move closer to pure rest. There is no need to follow these words anymore. They will continue if you need them, but you don't need to listen. You don't need to understand or remember or do anything. You can simply let go completely, drifting into sleep, natural and peaceful sleep. The sleep your body craves, the rest your mind deserves. Sleep now. Deep, peaceful, restful sleep. Let the cosmos hold you in its vast embrace. Let the darkness of space become the darkness of sleep. Let the silence of airless worlds become the silence of a quiet mind. You are safe, you are comfortable, you are peaceful, and you are drifting now into the deepest sleep, where dreams may come or not, where rest is complete, where everything fades except the gentle awareness of being, and even that will fade into sleep. Sleep deeply. Rest completely. The universe continues without you, and that's perfectly fine. Everything is taken care of. Everything is as it should be. You can let go of everything now and simply sleep, peaceful and deep, until morning comes and a new day begins, and you awaken refreshed and restored. But that is far away. For now, only sleep matters. Only rest. Only the peaceful darkness and the gentle fade into unconsciousness. Let it come. Let yourself go. Sleep is here, warm and welcoming. Drift into it now. Drift deeper, deeper still, into sleep, into rest, into the peaceful void where nothing matters and everything is well. Sleep now. Sleep deeply. Sleep peacefully. Rest completely in the cosmic embrace of the universe that birthed you, that sustains you, and that holds you gently as you rest. Good night, peaceful traveler. Sleep well.